Okay, we're going to take a look at this particular rhythm right now. This is one of the rhythms online. So let's take a look and determine whether or not this is a normal sinus rhythm. Now you already know bradycardia means what? A heart rate that's what?
Less than 60.
Less than 60. So tachycardia would be what?
Tachycardia more than 100. Say
Right,
160.
right, tachycardia. So there doesn't necessarily have to be anything inherently wrong with the PR, the QT, the QRS. It could just mean that the heart rate's either too fast, or too slow. But we still have to report it, don't we? Cool. All right, so let's take a look at this. The first thing we're going to do is we are going to take our calipers and we're going to measure the R to R peaks, okay? So let's open these up and let's see if the R to R distances are even, right? We're going to look at R to R's, which are ventricular, the ventricular rhythm, and P to P, which is the atrial rhythm, right? So R to R, 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 and R to R. All the R to R's look like they're about regular, right? So don't worry about whether or not you've pulled a 6-second strip. The machines automatically, when you push the button, will spit out a 6-second strip. That's what the machines are programmed to do. And then in about half an hour, 40 minutes, I'm going to bring out an ACLS AED monitor that shocks people, and it's got a monitor, and we can make different rhythms and things like that, so I can show you real time what it looks like. Let's look at P to P's now, shall we? So let's take our calipers and go from P, the peak of the P, to the peak of the P. So I'm measuring from what? From the very apex of the P's. Now, not everybody does that. For me, it's too confusing because some people will say, well, where the P starts to decline, it's like, yeah, no, that's just too confusing. Go to the peaks. It's much easier, and it all makes sense, and it all measures out the same. So from the peak of the P's, we're going to take this and measure the distance. Peak of the P regular. Peak of the P regular. Peak to peak regular. Same. 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 So what has this told us? The R to R's measure, they're regular. The P to P's are regular. There is a P for every QRS and a QRS for every P. So far, so good?
Yeah.
Cool. Now let's look at the heart rate. So let's try to find one of these R peaks that are on a solid line. Neither of these are, but this is, right? So we'll start from here. Let's count the large boxes between the two R peaks. 1, 2, 3, almost 4 large boxes, right? 4 goes into 300, 75, it's a one little less than 75, so around 74. How do we find more accurately? If we wanted to count the small boxes, we would say 5, 10, 15, 25. No, 5, 10, 15, sorry, 5, 10, 15, this would be 20, so about 19. 19 into 1500 is what? How many times does 19 go into 1500? 78. How about that? So you know, that's about more correct. Do you see how you can zero in on the heart rate just a little bit better? Now, is the heart rate within the normal range? It is. The P to P's are regular. The R to R's are regular. There's a P wave for every QRS and a QRS for every P wave. Now we're going to measure to see if our values fall within these levels. Okay? Let's see if the values fall within these levels. So what we're going to take is our calipers right now, and we're going to measure the QRS complex. Now the QRS complex should be between what? 0.08, which is what? 2 small squares, and 0.12, which is what? 3 small squares. So let me line this up. 1 on the Q, bless you. Okay, there it is. Now it's kind of hard to see. So what I'm going to do is I'm going to bring this down, put it on a solid line, and it looks like I've got about 3 small squares. About 3 small squares. So it's 0.12. So the QRS would be what? Normal. So you're going to write that down. Everything that we're talking about right now, you're going to write down when you interpret each of these rhythms, so that you get it, so you start to understand it. So the QRS is normal. Next we're going to check the PR interval from P to R. So let's measure from P to R. Peak of the P to the peak of the R. Pull it down. Now the PR we said is between 0.12 and 0.20, right? And it looks like we've got about 4 squares here. So about 0.16. Is the PR interval normal? It is. Check that off. Now we have to look at the QT, correct? So we're going to go to the Q. Now, where do we take it to measure the T? Not at the peak. Here's the T, but we bring it right to the point where the T starts to curve, right before it hits the isoelectric line. So we're right here. Right there. So you can almost draw a line and make it tangent to the curve. Tangent means where a line meets a curve at one point. We said QT is between 0.36 and 0.44, right? Let's take a look. So this is almost 40, isn't it? 0.20 and 0.20 is 0.40, right? So we are probably right around, say, about, I don't know, 38, 39, something like that, 40. Each of these are 4. So 0.4 from 4, about 36, 0.36. Is that normal?
Yes.
So now that you've identified and measured each of these, we would say that this is a normal sinus rhythm. This is textbook, guys. This is normal. This is what you want everybody's heart rate to look like. Does it? No. If they're on telemetry, there's a reason that they're on telemetry. Okay? It's not because they have a normal heart rate. It's because something's wrong. You want to do another one? Let's do another one. You starting to understand this?
Yes.
I'm so happy. Let's continue. How do I make this smaller?